Voyager 1 and Voyager 2 have been an eye to see what is going on in the large open space surrounding Earth and also find out if there are any living beings or aliens in space, as we all thought. It's been 45 years since NASA launched the Voyager 1 and Voyager 2 into space, that's around 1977, and NASA scientists may have completely forgotten about the probe. And right now, scientists claim that Voyager 1 is 23 billion kilometers from Earth, which means, by now, it will be beyond our solar system. Even though the Voyager 1 is very old, with an ancient style of technology, it has continuously sent strange images of what is going on in outer space to scientists, but the funky data that Voyager 1 sent back from interstellar space left NASA engineers scratching their heads. Keep watching as we discuss the bizarre image NASA's Voyager 1 space probe have recently sent to NASA scientists that left them confused about what space is made of. According to NASA, Voyager 1 left the solar system in 2012 when it entered interstellar space after crossing the heliopause, or limit of our sun's influence. Interestingly, Voyager 1 is still acquiring and transmitting science data accurately. It is still receiving and carrying out commands from Earth. However, it takes around 2 days to send a message and get a response due to its considerable distance from our globe. Despite the odd form of the telemetry data readings, we know the antenna is still pointed toward us since we are still in contact with Voyager 1. Even with the most powerful telescopes on Earth, the Voyager 1 probe is much too tiny to be seen. If we could see it on May 19, 2022, it would be in the direction of the zodiac Ophiuchus, the serpent bearer, which is high in the sky before dawn at this time of year and ascends into our sky before midnight. Beyond simply the communications gap, working with a system so far away and created so long ago presents several difficulties. The Voyager interstellar mission's goal is to continue NASA's solar system exploration beyond the space around the outer planets out to the edge of the Sun's sphere of influence and potentially beyond. This extended mission still characterizes the outer solar system's environment and looks for the heliopause boundary, the Sun's magnetic field's outermost limits, and the solar wind's outward movement. Measurements of the interstellar fields, particles, and waves undisturbed by the solar wind will be possible after the heliopause boundary between the solar wind and the interstellar medium has been penetrated. Not only was Voyager 1 launched into space, but Voyager 2 was also sent into space. Both probes are currently traveling away from the Sun and into a very far region of space, and NASA continues to manage both of them. At the same time, they capture disturbing images that will be very useful for research. Along with its twin, Voyager 2, Voyager 1 has been exploring the solar system since 1977. Initially, they were meant to be used for research on Jupiter, Saturn, their moons, and Saturn's rings. They were built to endure only 5 years during the two-planet expedition. After their initial success, engineers extended the mission's goals to include 2 extra big planets, Uranus and Neptune. The 2 spacecraft have explored 48 moons, for planets, various planetary magnetic fields, and several magnetic fields and rings. And what is shocking is that no aliens were found on these cosmos bodies. The spacecraft's yearly power output is reduced by around 4 watts, which limits the number of systems it can run. To save energy, the mission crew has shut off the equipment. According to NASA, the plan is to keep the Voyagers working through 2025. The 2 spacecraft are nearly identical. Both Voyagers were, however, transported in separate directions. After being launched to both Jupiter and Saturn, the 2 spacecraft diverged. Voyager 1 passed past Titan, a moon of Saturn, leaving the ecliptic plane and preventing it from traveling on to Uranus and Neptune. If Voyager 1 had failed, Voyager 2 would have been sent on a flyby of Titan, but Voyager 1 was successful. Thus Voyager 2's engineers sent it on to proceed to those 2 outer planets. Currently, the 2 probes are outside of our solar system. That's where the solar wind no longer impacts the probe. It is in the empty region of space between stars, 14 billion miles separate from Earth. Yes, it does not frequently send data to the Earth because NASA turns off all unnecessary systems to conserve energy. Even though NASA predicted that the Voyager's battery power would fail in 2 or 3 years, the Voyager continues its journey powerless and out of contact with us. The batteries have not failed, and its capturing cameras are still working efficiently as expected. At this point, we should applaud the engineers that designed, built, and managed it. They did an incredible job. The Voyager 1 and 2 share the same technology, however, there were minor performance variances brought on by slightly different starting settings. This was calculated in advance and purposefully employed to improve Voyager 2's capabilities over Voyager 1 marginally. Why? Because Voyager 2 would have the opportunity to change its objective from simply being a backup for Titan to taking into account Uranus and perhaps even Neptune as potential future Encounter targets. If Voyager 1 successfully achieved the primary science target of a Titan atmospheric occultation during the Saturn encounter. Two things were necessary to achieve these considerably farther off goals: the greatest amount of electricity and the best cameras. To do this, Voyager 2 was outfitted with a slightly hotter RTG, ensuring that she always had considerably greater power remaining, and slightly stronger visions were employed in Voyager 2's imaging systems, ensuring that the poorer light conditions received at the more distant planets could be handled. The picture data would have to wait for numerous other things to be completed before it could be delivered, and that includes creating a better encoding method, adjusting camera slewing to accommodate for longer exposure durations, and constructing larger receiving dishes. Fortunately, those tasks were completed in time for Neptune. The incorrect data comes from the Attitude Articulation and Control System, or AACS, which is onboard technology that monitors, reports, and modifies the vehicle's location in space. The system maintains an antenna directed towards Earth, allowing it to transmit data back home. Another question that should spark our interest is whether Voyagers 1 and 2 will be able to return to Earth someday. Unfortunately, the answer to this question could disappoint you. Plotting paths in space is something we are quite good at. We know where the Voyagers are going, and we know for sure that they will never again get close to any planet in our solar system, and it will be a long time, tens of thousands of years, before they ever come close to another solar system. But don't worry, getting them back won't provide much more information. If we could inspect them, we could learn more about what it's like for a spacecraft to spend decades in orbit. Aside from that, they'd make interesting museum pieces, but they don't have any extra scientific data to provide beyond what we've received by radio. And also, you might want to know if Voyager 1 and Voyager 2 will continue to move in space forever or will be hit by some obstruction and eventually get destroyed. Neither spacecraft will collide with anything. It isn't easy to fathom how far away the star systems are and how little matter exists between them. Never is a long time, but as far as we can tell, neither Voyager will collide with anything sizable. However, they will hit minor details, as dust and gas abound throughout our solar system and interstellar space. Even dust hits may scrape the spacecraft's surface at the speeds the Voyagers are moving, which is about 15 kilometers per second. A BB-sized particle can easily ruin an instrument or deactivate the spacecraft. The odds of such an encounter occurring during the spacecraft's journey are extremely low, but such strikes will likely change the look of the spacecraft over millions of years. However, it is extremely doubtful that either Voyager will be observed again by humans or other creatures. We can only track them now because they have active transmitters. We will lose communication with the Voyagers sometime in the next decade because their equipment will run out of power. They will be hard to trace after they cease broadcasting, and we will never see them again. Even if humanity develops the ability to go as far as the Voyagers, locating them will be difficult, comparable to saying, "I've put a grain of sand in the Pacific Ocean and trying to find it will be much worse." Do you think NASA should send more Voyagers into space to learn more about the solar system before transporting human astronauts to the Moon? The James Webb Telescope, JWST, is doing a good job as well, and has released new images.